Good day, math learners! In this video, we will talk about the concept on the quartiles of the ungrouped data for case 3 and case 4. Let us try to recall the different 4 cases in solving quartiles of the ungrouped data. So let n be the number of values in a set of data. So for case 1, so if n here is an odd number and the product of 1/2 and the quantity of n minus 1 is also an odd number, therefore we will be using case 1. Then for case 2, if our n is an odd number and the result of the product of 1/2 and quantity of n minus 1 is an even number, therefore it falls under case 2. Then for case 3, if n here is an even number and it is divisible by 4, therefore it falls under case 3. Then lastly, for case 4, if n is even and it is not divisible by 4, therefore it falls under case 4. So in this video, we will focus more on case 3 and case 4. So for case 3, so we will be using case 3 if n is even and it is divisible by 4. So the quartiles of n sorted data where n is even and it is divisible by 4 are the following. So these are the formulas in finding the quartiles of the ungrouped data for case 3. So we have the first quartile, so that is equal to the mean or average of the two formulas 1/4 times n and also 1/4 n plus 1. Then for the second quartile, that is the mean or average of 1/2 n and 1/2 n plus 1. Then for the third quartile, still it is the mean or average of 3/4 n and 3/4 n plus 1. Example number 1. Find Q1, Q2, and Q3 for the following sets of scores of 12 students. Given the following scores: 48, 44, 24, 20, 23, 46, 50, 28, 31, 40, 21, and 49. So first, we have to identify the n of this given problem. So n here is equal to 12 since we have 12 students in the given data. And since 12 here is an even number and it is divisible by 4, therefore this problem falls under case 3. So the second step is to arrange the scores in ascending order, meaning to say from smallest to highest. Then number them consecutively from 1 to n is equal to 12. So I have here the table of scores which is arranged from smallest to highest. So we have 1, 2, 3, 4, 5, 6 until 12 since we have a total of 12 students. And as you have noticed the score here, so we begin with 20, 21, 23, 24, 28, 31, 40, 44, 46, 48, 49, and 50. So this is now arranged from smallest to highest. After arranging the set of scores from smallest to highest, we will now find the value of our first quartile. So the first quartile can be solved using the mean or average of 1/4 times n and 1/4 times n plus 1. So we will present this through the tabular form. So let us begin first with 1/4 times n. N here is 12 since we have a total of 12 students. Then substitute, we have 1/4 times 12, it gives us 3. So 3 here is not yet the final answer. This is the location of the score. So we have the third score. So the third score from the given table here is equal to 23. Then, for the next formula, we will be using 1/4 times n plus 1. So again, apply the PEMDAS rule. So we will multiply first 1/4 and n here is 12. So it gives us 3 plus 1. Therefore, it gives us 4 and that is the fourth score. So the fourth score from our given data here is 24. So the fourth score is 24. Since we are looking for the mean or average of the two given formulas, therefore, we will add the given values of each score. We have 23 and 24. Then divide it by 2, therefore, the value of our first quartile is 23.5. Then, to interpret the results, since our data is all about the scores of 12 students, so we can interpret it this way. So this means that 25% of the students scored lower than or equal to 23.5. So next we have to solve the second quartile. So the second quartile can be solved using the two formulas 1/2 times n and 1/2 times n plus 1. So we will first use the formula 1/2 times n. So n is 12, 1/2 of 12 is 6. So therefore, we will locate the sixth score from our data and it gives us 31. Then, for the second formula, we have 1/2 times n plus 1. 1/2 of 12 is 6. Plus 1, it gives us 7. Therefore, locate the seventh score from the given data. We have 40. Then, since we are talking about the mean or average of the given two formulas, therefore, the value of the second quartile can be solved using 31 and 40. So 31 plus 40 divided by 2. Therefore, the value of the second quartile is 35.5. This means that 50% of the students scored lower than or equal to 35.5. So for the third quartile, the third quartile can be solved using the mean or average of 3/4 times n and 3/4 times n plus 1. So we have 3/4 of 12 is 9. So from the given data, the ninth score is 46. Then the next formula would be 3/4 times n plus 1. 3/4 of 12 is 9. 9 plus 1 is 10. Therefore, locate the 10th score of the given data. Therefore, it is 48. Then after which, take the average of 46 and 48. 46 plus 48 divided by 2. Therefore, the value of the third quartile is 47. This means that 75% of the students scored lower than or equal to 47. Another example would be, find the first quartile, second quartile, and third quartile of the scores of 16 students. Given the scores 35, 30, 39, 31, 29, 28, 38, 30, 24, 25, 31, 27, 30, 24, 27, and 28. So first, we have to identify n in this given data. N is 16, and 16 is an even number. At the same time, it is divisible by 4. Therefore, this problem falls under case 3. The second step is to arrange this set of scores in ascending order from smallest to highest. Then number them consecutively from 1 to n equals 16. So you can present that one through a tabular form. So as you have noticed, there are numbers which are repeated. So even though these numbers are repeated, still we have to write it since the n here is equal to 16. So let us now begin with quartile 1. So it is the average of these two formulas. So 1/4 of n here is 16. 1/4 of 16 is 4. Then we have to locate the fourth score, which is 27. Then the second formula, we have 1/4 n plus 1. You multiply first 1/4 and 16. It gives us 4 plus 1. So that is 5. Locate the fifth score, and that is still 27. Then, since we have located the fourth and the fifth scores of the given data, therefore, take the average of these two scores. We have 27 plus 27 divided by 2. Therefore, the first quartile is equal to 27. This means that 25% of the students scored lower than or equal to 27. Let us now find the second quartile. So the second quartile is the mean or average of the two given formulas. So 1/2 of n here is 16. 1/2 of 16 is 8. So locate the eighth score from the given data. It gives us 29. Then the second formula, we have 1/2 n plus 1. 1/2 times 16 is 8 plus 1, 9. Locate the ninth score. It gives us 30. After which, take the average of the two scores, 29 and 30. So 29 plus 30 divided by 2. So the second quartile is equal to 29.5. This means that 50% of the students scored lower than or equal to 29.5. Lastly, we will now find the third quartile. So it is the average of the two given formulas, 3/4 times n and 3/4 times n plus 1. So 3/4 of 16 is 12. So locate the 12th score of this given data, and that is 31. Then the next formula, we have 3/4 n plus 1. So 3/4 times 16 is 12 plus 1. It gives us 13. Locate the 13th score, that is equal to 31. And then take the average of the two scores, 31 plus 31 divided by 2. Therefore, the third quartile is equal to 31. This means that 75% of the students scored lower than or equal to 31. Let us now proceed to the last case, which is case 4. We can only use case 4 if n is even and n is not divisible by 4. So, the quartiles of n sorted data where n is even but not divisible by 4 are the following. So, these are the formulas in finding the quartiles of the ungrouped data for case 4. So, this will be for the first quartile. We have 1/4 times n plus 1/2. Then for the second quartile, we have to take the average of the given formulas of 1/2 times n and 1/2 times n plus 1. Then for the third quartile, we have to use 3/4 times n plus 1/2. So let us now consider this example. Find the first quartile, second quartile, third quartile for the following sets of scores of 10 students. Given the scores of 24, 29, 30, 16, 20, 22, 28, 21, 19, and 27. So first, we have to identify our n in this given data. N is equal to 10, and 10 here is an even number, but it is not divisible by 4. Therefore, this problem falls under case 4. The next step is to arrange the set of scores in ascending order from smallest to highest. Then number them consecutively from 1 to n equals 10. So we can present that one through the table. So we will begin with 16, which is the smallest score. The 19, 20, 21, 22, 24, 27, 28, 29, and 30. After arranging the set of scores from smallest to highest, we will now find the value of the first quartile. So the first quartile can be solved using the formula of 1/4 times n plus 1/2. So using this formula, our n is 10. Simply substitute from the given formula. So 1/4 times n or 10 plus 1/2, it gives us 5/2 plus 1/2. Since they have the same denominators, therefore we can easily add the numerators 5 and 1. So it gives us 6, then copy the denominator 2. Then simplify. 6 divided by 2 is 3. Then let us now locate the third score from the given data, and that is 20. Therefore, the first quartile is equal to 20. This means that 25% of the students scored lower than or equal to 20. For the second quartile, so we will take the average of the given formulas 1/2 times n and 1/2 times n plus 1. So 1/2 of 10 is 5. The fifth score here is 22 from the given table. Then the second formula, we have 1/2 times n plus 1. 1/2 of 10 is 5 plus 1 is 6. So the sixth score is 24. Then let us now take the average of 22 and 24. 22 plus 24 divided by 2. Therefore, the second quartile is equal to 23. This means that 50% of the students scored lower than or equal to 23. We will now solve for the third quartile. The third quartile can be solved using the formula 3/4 times n plus 1/2. So 3/4 times 10 plus 1/2, it gives us 15/2 plus 1/2. Since they are both similar fractions, therefore you add the denominator 15 and 1, then copy the denominator 2, therefore it gives us 16/2. Then simplify, it gives us 8. Then let us now locate the 8th score from our data. So the 8th score is 28, and that is our third quartile. This means that 75% of the students scored lower than or equal to 28. Another example would be, find quartile 1, quartile 2, and quartile 3 for the following random scores of 18 students. Given the scores of 35, 30, 39, 40, 31, 29, 40, 28, 38, 30, 24, 25, 31, 27, 30, 24, 27, and 28. First, we have to identify our n in this given data. N is 18 since we have a total of 18 students from this data. Since 18 is an even number and it is not divisible by 4, therefore this problem falls under case 4. So the next step is to arrange the set of scores in ascending order, then number them consecutively from 1 to n equals 18. So we will begin with 24, 24, 25, 27, 27, 28, 28, 29, 30, 30, 30, 31, 31, 35, 38, 39, 40, and 40. After arranging the set of scores from smallest to highest, so we will now find the first quartile. So the first quartile can be solved using the formula 1/4 times n plus 1/2. Then substitute n, which is 18, to this formula. We have 1/4 times 18 plus 1/2. 1/4 of 18 is 9/2 plus 1/2. It gives us 10/2. Simplify, it gives us 5. Then let us now locate the fifth score from our given data. The fifth score in the given data is 27. Therefore, the first quartile is equal to 27. This means that 25% of the students scored lower than or equal to 27. For the second quartile, we will now take the average of the values of these given two formulas. So 1/2 of n, 1/2 of 18 is 9. The ninth score is equal to 30. Then in the second formula, we have 1/2 times n plus 1. 1/2 of 18 is 9. 9 plus 1 is 10. The 10th score from this data is 30. So we will now take the average of the two scores. So 30 plus 30 divided by 2. Therefore, the second quartile is equal to 30. This means that 50% of the students scored lower than or equal to 30. Lastly, we will now find the third quartile. The third quartile can be solved using the formula 3/4 times n plus 1/2. So we will substitute n with 18. 3/4 of 18 is 27/2 plus 1/2. It gives us 28/2. Then simplify. That is equal to 14. Then the 14th score is equal to 35. Therefore, our third quartile is equal to 35. This means that 75% of the students scored lower than or equal to 35. And this ends our lesson on the quartiles of the ungrouped data for case 3 and case 4. Thank you.